Well, it's time to look at another type of quadrilateral, and that is a kite. Now, kites have some special properties, special theorems, and one of those, if a quadrilateral is a kite, then the diagonals are perpendicular. Another property of a kite is it's going to have exactly one pair of opposite angles that are congruent. And it's actually that theorem that we're going to be able to use in this first example, where we're told that if angle BAD is equal to 38 and the measure of angle BCD is equal to 50, find ADC. Well, let's identify this first. Okay, I guess I'll use this color right here. All right, so we're told that BAD, measure BAD, that would be this angle here, is 38. And angle BCD, which would be include these two angles right here, is 50. And then we're asked to find the measure of ADC. We're trying to find this angle right there. All right, now, so if a kite has exactly one pair of opposite angles that are congruent, well, I can see that BAD is 38 and BCD is 50. Well, those are opposite angles, but they're not congruent, which means that this angle ABC, this angle, and BCD, the angle we're trying to find, well, those have got to be congruent. So let's set up to solve this. Let's say that angle ADC equals X. Now, it's a quadrilateral, so there's 360 degrees of interior angles in a quadrilateral. And we know that angle BAD is 38. And we know that BCD is 50. And because it's a kite, we know that these other two angles are congruent. So we could say this is time plus 2x. And we're just trying to find x, which is ADC. But ABC is also congruent with ADC. Well, let's see, 360. Let's solve this thing. 360, that's 88 plus 2x. And let's subtract 88 from both sides, okay? And once we do, then that's 272 equals 2x. And let's divide both sides by 2. And once we do, we can see that x, which we've defined as the measure of ADC, is 136. So this angle here, then, is 136, because this angle here is also 136. We got one pair, exactly one pair of opposite angles that are congruent. That's one of the properties, one of the theorems having to do with a kite. Now let's look at a side measure here. Okay, so we're told that if BT, let me put this in a different color. BT is 5. That's this measure right here. And TC is 8, so this is here. And we got to find CD, which is this segment CD. But look, I can see that CD is congruent to CB. Now, I don't really know that BT and TD are congruent. I kind of would think they would be. But I do know that CB and CD are congruent. And the diagonals, another property, the diagonals form a right angle. So this is a right triangle. Okay. And the hypotenuse in this triangle up here of CB, the hypotenuse, that's the hypotenuse. So I've got two legs of a right triangle, and I want to find the hypotenuse, and this is going to be congruent to this. So if I can find CB, well, then I know what CD is. Well, let's use Pythagorean theorem. So we got 5 squared plus 8 squared equals C squared. And C in this case is the measure of CB. Again, CB and CD are congruent. Let's see, 5 squared is 25, and 8 squared is 64. So that's going to be equal C squared, the hypotenuse squared, and it's 25 and 64 is 89 equals C squared. And if we take the square root of both sides, we got the square root of 89 equals C. Square root of 89. Well, 81 is a perfect square, but that would leave us with just 8 left over. Yeah, I could simplify that a little bit if I wanted to, but I think for our purposes today, I'm going to leave this as the square root of 89. You know what? I mean, I'm going to simplify it. Nope, I can't. I can't simplify it. Nope, square root of 89 is it. So this is the square root of 89. Kites. Go fly a kite, man.